Hello, everyone. I am Christina Lee. I am an Android engineer at Pinterest, and I'm here to talk to you all today about React Native. Now, a little bit of background first. I have not always been at Pinterest, and indeed, I'm actually a recent addition to the family there. Before that, I worked at a startup called Highlight, otherwise known as MathCamp Incorporated. Pictured here, it was a great group of people, but as you can see, we were small but mighty. And in the startup world, you are constantly fighting to stay alive. And so we really needed to iterate quickly in order to be relevant and to make something that users wanted. And so when I joined the company, I joined thinking I would work on the Highlight app, but quickly we realized that there was more to it, and we wanted to iterate, so we ended up quickly building out other successive versions, starting with Roll, going to View, and ending up with Shorts shortly before our acquisition. And so this is a lot of apps. They were all built from scratch, and they were all built several months after each other. And what we realized was we really just couldn't move fast enough to keep up with what we needed to do to stay alive as a company in the social media space. Why? Well, it varies by platform. Indeed, it's almost exactly the opposite by platform. On Android, I can upload an APK almost any time I want. There are some limits, but really, you upload it, it takes a few hours to roll out to your users, and that's great. But of course, the skeleton in the closet of Android is fragmentation and low adoption rates. So I can upload those APKs all I want. It doesn't mean my user's actually going to get them. So that's bad. On iOS, we have almost exactly the opposite problem, because of course on iOS, Apple has trained users to update their software by nagging them with notifications. Great for developers, maybe not so much for users, but the adoption rate is high. Of course, the opposite side of that, though, is that now, in order to get your app out to users, you are gated by people at Apple reviewing your app. And of course, it's not just a review, they can also reject it. And sometimes this happens even when you think it's a very minor change that you're making. We've had things in our app that were there for 6 months and then suddenly got rejected, even though they had been there all along, just because you have someone new. And so this introduces a ton of risk into your process. You don't control when your app makes it to your user. You are relying on a company whose best interests are probably not in alignment with your best interests. And here's a graph to illustrate what this looks like on iOS in particular. These are review times for the last year for iOS apps. That spike right there, that was when we were building out View, and it was up to 2 weeks before anybody would even look at our app. Not just review it, before they would look at it. And then we had several days after that of review before we would get an acceptance. This is a tremendous slowdown. This was a 2x on how long it took us to get our app out to our users. Of course, now it's lower, it's down to a couple days, but you can't always rely on that because, of course, it can spike in busy seasons. So we needed a new tool. Now, I gave you the spoiler with the name of this talk. That tool was React Native, go figure. And just to give you a little context on why, around this time, React had gotten really popular. Facebook didn't expect the success of React, but it really just kind of took off overnight. And so they quickly did an internal hackathon project for React Native in 2013. And soon after some iterations and stabilization, in 2015, they released the iOS version early in that year, and later in the year, Android. And this is a chart of Google Trend data. That line at the top, the red line, that's Android development. It's been pretty high. Interest there is great. The blue line, iOS development. And that upward trending yellow line, that's React Native. So Google is telling us there is a lot of interest, it's consistently growing, and indeed it's already overtaken Android development interest. Now, why is that so? Well, it has several claims to fame. First, JavaScript. We all know why that's good. We'll talk about it more later, but suffice to say that being able to write native apps in JavaScript is a claim to fame. Also, React has a great paradigm, which is that data flows down. This derives some very good properties for our development, which we'll also go over later. And then also, it brings that web dev experience to native. And if anybody here is a native developer, as I expect a lot of you are, you know that our experience has never been as good as web's experience. We have to wait for compilation times, we have Xcode, and sometimes it's buggy, and we have app code if we're doing JavaScript, which is a lot better for us. And so this brings that web experience to our development as well. Now, for our startup, this solved several issues. One, iteration speed. That thing that I started this talk with, all of a sudden with code push, we're not gated by other people. We can get our code into the user's hands when we want to. Second, every startup knows the struggle of limited resources. You are trying to do a lot with a little. And the promise of shared code, it's like that light at the end of the tunnel that with one person I can write for web, native, and both iOS and Android. Now, this sounds great. If you're like me, I'm like, all right, React Native, we're sold. But of course, reality is a little bit different in practice. It's not always quite so peachy. And so I'm going to go into some of the pros and cons, but first, I just want to pause to give you a little history on React itself. Because of course, React Native is a derivative of React, and if you're not here as a web developer, you probably haven't worked with React, and this might be a bit confusing. So, core components of what React is. It is a view manager based on components. It uses a virtual DOM, and it passes its data with immutable properties. And I'm going to go over those in a little bit more depth here. So, as a view manager, it gives you all the things that you would expect. You have to implement a render function because, of course, this is a view. We need it to show up. But also, you get your lifecycle callbacks. You get, view will have props and on component mounted and all of that. And as it's a view, you probably also add some styles in there. And so what does the most simple case look like? Well, here's a React component, and what this component is doing is it's drawing a gray line in between cells. It's just a separator view, that's it. And this is about as simple as it can get. You see that I'm declaring my component on the first line, I'm passing it those immutable properties, and then I have a view in here, and I'm putting some styling on the view, which makes it a gray line. Now, had I wanted to do something more complicated, I could have added these sort of lifecycle callbacks. I could have done something in a constructor, etc. And also, what I left out of that first slide was the styling. Again, you don't really need to understand this. It's just styling that makes it a gray line, shortly less than the width of the phone. Now, in terms of the virtual DOM, why do we care? The big point here is just that the virtual DOM makes rendering smarter, which makes it faster. And that's because instead of re-rendering the entire view hierarchy, what it does is it keeps the old and it keeps the new, and it does a diff on them. And so then we go down that tree and we re-render only the part that's changed, the very smallest amount that we need to re-render, which of course is a great performance gain. Why are properties important? Well, it ensures coding best practices. The fact that properties are immutable and passed into a component means that data always flows downward, and this is one of React's claim to fame. It controls how you're communicating in your app, which makes it much more easily extensible and a lot easier to debug as well, because the data flow is predictable and it's easy to trace. Okay, it's very important to note that React is a view layer paradigm. It is not a state management layer. And you guys might be familiar with things like Redux and Cycle.js, and they work really, really well with React and React Native. They work hand in hand, but those are two different things. This is for view management, those are for state management. So in summary, React key points to understand: view management, it uses components and properties to control how data flows, and it has that virtual DOM for smart diffs. Now, how does that tie into React Native, which is what we actually care about? Well, of course, React Native is built off of React, so they share that same structure. But what it adds is it adds this bridging logic to the native side, because the rendering is still going on the native side. So we need a way to go from JavaScript back to our native platform. Additionally, it wraps and exposes a bunch of native modules. So if you're an iOS developer and you're using UI image view, then that's going to be exposed to you for your React Native app. Okay, now that we've gone over a little bit of that, we can go into the actual pros and cons. And here's a list, and I'm going to dive into each of these more carefully and more in detail. Now, I will say that they're sort of in order of most important, which is to say that those first two, those are the elephants in the room. Those are the ones you've probably heard about and the ones that are going to have the biggest, most outsized impact on your development. So what is code push? I've mentioned it before, and in short, code push is a way that you can push updates over the air to your users without going through the App Store. How does that work? Well, It's a central repo. And what you do is when you integrate your native apps with code push, they'll start pulling that central repo, and you can push updated code there. And if there's a new version that your client code does not have, it'll download it. And then when the app restarts, it'll run that code instead of the code that you shipped in your APK. So, why is this good? I probably don't even need this slide. You know why this is good. You can hotfix bugs, you can change features on the fly, and you can do a ton of really incredible stuff with A and B testing. There's nothing not to love about this. Except, of course, there always is something not to love about everything. And some of the things that are downsides of code push are that it does use data. You are downloading code onto someone's phone. If you do not do this in a kind way, you're going to really piss off some users, especially in the US, where data is both limited and expensive. I've heard that's not the case everywhere. Very jealous, but in the US it is. And also, because you're downloading things, timing can get tricky. And that's because when you are developing native apps, people download your apps once, and you expect them to be there when you're running your app. But now, if we're pushing code after the app has started, that code is coming in while the user's already in our app. And we have to figure out what the best time to integrate that new code into our user's experience is. And there are great policies that are out there by default, but it is a decision that you need to account for, especially if you're doing code push for onboarding, which is one of the areas that Pinterest is most excited about React Native for. It also complicates the build process. This should go without saying. Right now, your companies probably all have very robust Android and iOS deployment processes. Well, now you can push code to them over the air, and you need some way to manage that. And also, there's Apple. We always have to be respectful of their terms of service, and code push can get a little murky. Google does not have a review process for its apps when you're uploading to the store, so shrugsy on that, it should be okay. But of course, Apple has people who are looking at your apps and approving them. So if they look at an app and approve it, and you change that app, that can get really tricky. And so the good thing is that this is part of the terms of service. It does align with Apple's user policy. You do not need to read all of this, because the most important part of it is here. And that is that we can do this provided that these scripts and code do not change the primary purpose of our application. So that sounds great. We can do this. Apple says so. But of course, this means that you're in a situation where you have to use your best judgment and then really hope like hell that that best judgment matches Apple's best judgment as well. Because we don't know what they're thinking. We don't know how big of a change changes the app's purpose. And so this is a line that you have to walk, and the risks are there, and there's something to be considered. So, in summary, using React Native, it gives you access to code push, and having access to code push increases your developer velocity, and it also allows you to put out hotfixes. So, the second big one, cross-platform code. Now, in theory, cross-platform code is the dream because you write it once and you run it anywhere. Android, iOS, web, it's all the same. You don't need 3 teams anymore, you have one. And additionally, it means that there's feature parity for all of your platforms because, of course, they're all running the same code. So we don't have that case where on iOS you push that feature and the Android people are really feeling left out. That's a bad feeling, so it's great for our users. Moreover, when we open up web to our native development process, web has much more resources than we have, so we're opening a vast quantity of new knowledge and new developers to something that traditionally has had a lot of trouble recruiting good talent. But, of course, there are caveats to that. The first of those deals with the one-to-one paradigm. So we say write once, run anywhere, in theory, but of course in practice, that's just not quite where we are yet. So there is branching logic that you're going to have to introduce. And why is that? Well, because of course, canonical example, on iOS, we have the nav bar on the bottom. On Android, it's on the top. And so now when you're writing your React app, you have to take that into consideration. You have to branch that logic and change how your UI looks based on platform. So it's not quite write once, it's write once and a half. Write it once and then tweak it for each platform. And what that means is that you're introducing a lot of code into a single monolithic code base. And that means that it can grow quite a bit. And this is something that we should think about because, of course, while iOS and Android and web do duplicate a lot of code, they also have a lot of tricks and features that are very particular to that one platform. All of those are now going to come under the same code base. Additionally, we can't really say that React Native is one-to-one yet. I told you before that it launched first with iOS, and that legacy is still in effect right now. iOS launched first, it's more fully developed, and Android is still trying to catch up. And while I do think this gap will close soon, we're not quite there yet. Caveat number 2. When we talk about having this JavaScript for native development and being able to use people from the web for our native development, the caveat is that your entire app has to be in React Native for that to be true. To get rid of your Android and iOS departments, it needs to be all React Native. But of course, React Native has some performance issues. And those performance issues means that in all likelihood, you're not going to have a full React Native app, you're going to have a hybrid app. And if you have a hybrid app, well, you're going to still need some Android and iOS developers, which is great for me because it means I'll still have a job. So, looking forward, I do think that these things are going to be better, and I think they're going to be better soon. RN is an incredibly active development. Every 2 weeks, we get a new update. So I do think feature parity for Android and iOS will be coming sooner than we think. Also, because we have such interest in React and React Native, I think we're going to see a lot of open source community efforts towards helping us with the run once, or write once, run anywhere paradigm. So people are going to get fed up with branched logic for iOS and Android, and they're going to come up with solutions, and that's going to benefit all of us. And lastly, RN is not yet finalized. It's not even close to being a 1.0 framework, and because of that, there's no room for optimizations yet. You can't optimize something that might not even be around in the final version. So once this gets to 1.0, I think we'll begin to see optimizations that mitigate performance issues. Okay, some other benefits. Like I said, we have access to web technologies. Why is this good? Because web moves way faster than we do on native. I hate to say it, but it's true. It moves much, much faster, and they have a great history of state management, which is something that we just don't quite have on native because we're given activities, we're given view controllers, and we kind of have to move in the direction that Google and Apple said because bucking that trend can be costly, and it can be like pushing a rock uphill. It's just going to come back down. And so we have things like Redux and Cycle that we suddenly get access to that makes state management a hell of a lot better and means that we as developers are more productive and less likely to make errors. Additionally, it encourages reactive programming because of the history of the web. They don't have all of these databasing layers like we do on native, so that's something of interest to us too in pushing us towards best practices. Okay, in terms of developer velocity, I've already briefly touched on this, but I can't emphasize enough what it means to go from 3-minute compile times to 2-second hot loading. Here, when you're developing code with React Native, you can make a design decision and implement it in your code and immediately see that in your phone or in your emulator. And this is important because, of course, one of the big issues with development is interruption, because you get in flows as developers, and when you have to compile something for 3 minutes, you suddenly get really distracted by Facebook or Twitter or whatever else it is. I do it too, so I know that this is the case. And then when you pick up your code, you're like, what was I doing again? And so this is very costly, right? And so having these 2 to 3 second loops means that you are never tempted to walk away from your computer to talk to your coworker or any of that. You can stay in your flow as a developer, and this is a huge gain. Additionally, we now have access to all of the debugging and testing that the web has access to, and they have access to a lot. Traditionally, they're way better about integration tests and things of that nature, and suddenly that all becomes applicable to our native apps too, and we get it for free, and that's really, really powerful. We have all of the resources of Google's Chrome development features, and so we also get these fun features like time travel, which is much harder to implement in native, and the principle of time travel is that we have properties flowing through our React app, and properties are just fields with values, so we can store those. And if we store the series of properties that flow through our app and define the state of our app, well, then we can scrub back and forth between them. And in particular, we can scrub back to that property right before our app crashed and look at the properties right when our app crashed and figure out what changed to cause our app to crash. And so that's really, really powerful. Instead of looking through your code and being like, where is this? You know exactly where it is. And debugging tools like that, they save time, they're gonna make your manager happy. Additionally, I skipped over this. This is probably the most underrated feature of React Native. They surface warnings in the UI. And if you are anything like me, when you compile your app, there are going to be warnings and you're going to ignore them. Why? Because they are down at the bottom of your IDE in that compilation output. I guarantee, though, if your warnings are surfaced in a yellow box that covers the bottom half of your screen, you are going to be very motivated to fix them, and very quickly. So this is great. I do not have any warnings in my React Native apps, unlike in my native apps, and this is something that you might not expect, but it is really, really useful. Other benefits, again, I've touched on it. You have the entire resources of the web dev community at your fingertips. And they are large, and they are smart, and they are incredibly helpful in terms of documentation, open source, and even just people to hire. It is way easier to hire really good web devs than really senior Android engineers. Also, React Native has assurances from some of the biggest companies in tech that they're going to devote time and resources to it. Not only has Facebook come out on record saying that this is in their long-term vision, they've also secured agreements from both Microsoft and Samsung that they will support this. So you're going to be able to run React Native apps on things like Samsung smart TVs, watches, and also Windows, iOS, and Android devices. That's incredible. Almost anything you can dream of, you can run React Native on with these assurances. So to review, we have a ton of pros for React Native. Hot bug fixes, being able to push code when you want to, not when someone else says it's okay. Sharing code across your native clients. Faster development, and access to all the benefits of the web. This sounds awesome, but of course, it can't all come for free. I wish it could. So, cons. Let's get into them. Here's a list, and what I'm going to say about this list is that everything flows down from performance. So we start with performance, and it causes us to do some other things that really hold us back. Why is performance an issue? It's an issue because we have a single JavaScript thread. And what that means is that all of the stuff that we want to do with our app, it has to happen on that single thread. We have to handle our touches, we have to make our calls and business logic there, and then after that, we have to send it all back to the native side. At the end of each event loop, instead of just rendering it, we have to send it somewhere, have it decoded, and then render it. So we're adding extra steps there. And this all occurs via a bridge, and this bridge is synchronous, and we have to unmarshal things to get them from JavaScript back to native, so there's a lot of extra work going on here. Now, the fine folks at Airbnb, Leland and Philippe, I think gave the best description of the React threading model I've ever seen. So with their permission, I'm going to share it with you today. And basically, I'm going to skip this slide and go straight to the diagram. What's happening here is that when we get UI things, we're getting them on the main thread, and then we're passing them off to React. And while we're in React, we're doing the logic that we need to update the views, figuring out what should change. Then that virtual DOM system is going to spit out a diff, and that diff is going to be sent to this shadow thread. And what it's going to do is it's going to calculate everything we need for layout. Now, once it does that, it's going to have to still pass it back to the main thread in order to be rendered, because, of course, everything needs to be on the main thread for our UI. So you can see here, this all still has to be in that 16 milliseconds needed for 60 FPS, and this is a lot of context switching. It's a lot more than on native. And so where are you going to see this raise its head? Well, a lot in navigations when you're sliding screens in on top of each other. Also in list views, when you're scrolling, when you're animating images, all of that heavy lifting, you're probably going to start seeing this affect you. Now, a lot of these have workarounds. We had issue with our list view, and we optimized it, and we set flags, and we did other things, and we loaded less data, and we did render ahead, and all of this stuff. So a lot of these things that I've pointed out, there are things that you can do to mitigate them. But you have to sit there and wonder, how many times do I want to have to mitigate an issue? Now, this leads to interfacing. One of the things that you can do if performance is bad on your single JavaScript thread is go back to native, where you can have these multi-threaded environments. You can push your expensive functionality there, but of course, the trade-off there is that this is no longer just your web dev team. Now you're getting back to the Android and the iOS engineers, and so that premise of having the one team and writing it everywhere suddenly evaporated. And, there's some finicky things, like you have to write this in Objective-C, which if you're a Swift developer is not a fun prospect. Now, what does this mean for code push? You've probably already connected the dots. It means bad things. We can't push code to native. We can push it to code push with our React Native layer. So what does that leave you? Well, if you want to, update your app on the fly, you're suddenly going to have to open up the architecture for your native side, making it more generic, maybe putting in functions that you don't yet need, but you might need if you want to code push something and have it interact correctly. But really try to resist this temptation, because these are things that are going to introduce bugs. And I know it because I've tried it, and I've made this mistake for you. So when you expose functions you don't yet need, there's a high likelihood that you're not going to test them very thoroughly, because they are not on the main code path. You're going to test your main code path, and it's going to be great. And then when you code push something and you say, I built in this back door, I can use that, you're going to find out you didn't necessarily write it correctly. So roll that one back. Also, it's going to add code bloat. Anytime you're writing code speculatively that you don't yet need, this is a bad situation. And you may say, okay, I need this function, but let me just make the type a little more generic. Let me change this to any. So I can use it for this case, but I can also use it for this case just in case. But of course, types are our friends because they help us reduce our mistakes. They catch things that we as humans cannot keep in our head all at once. The compiler becomes our use case. It'll tell us when we've messed up. And when you make things generic, it stops doing that. So I have indeed introduced bugs by making things generic, thinking everything was fine, and then finding out it wasn't. Now, this leads into a bigger problem of more general architectural complexity, and that's because when you have a hybrid app, you need to communicate. You have part of your app in your native client and part of it in JavaScript, and they need to be organized. They need to communicate with each other. They need to be synchronized. So now you have this bridge, and you have to communicate back and forth, and let me tell you, that bridge is optimized for communication in only one direction. And on that note, side note on communication, if you're trying to talk from JavaScript to native, you can call almost anything you want. And why is that? Because all you have to do is wrap your method in a module and expose it to your React app, and it can call it. And this is exactly what we want. This is great. In the other direction, not so much. When we're trying to have our native app talk to our JavaScript, things get a lot more complicated. If you want, you could change the top-level properties, but you should really only be doing that if they're top-level properties. You shouldn't use that as a control flow. You can use callbacks, but they're marked as experimental for a really good reason, which is that they're kind of clumsy and a little bit hard to use. And then you're left with the solution that almost everybody goes with, which is events. But of course, events are global, and they can be consumed anywhere, and now we have loose coupling, and they're really less than ideal. Namespacing issues can arise if you're using components in multiple places, like you have some component that's in a list multiple times. So this is less than ideal, and in total, it just means that when you try to go from native to JavaScript, your life is not going to be too happy. So getting back to that complexity, we can talk from JavaScript to native pretty easily, but when your database and networking layer is in native, you need to talk back to JavaScript. You need to be able to pass data to JavaScript, and it's really, really hard to get this right over a synchronous bridge. We were working in a photo sharing app. We had to send 20, 30 photos at a time for a list view, and when you're doing this synchronously on a single thread, it means that you have to start using pages very aggressively, or you're going to drop frames almost immediately. And when you're using pages, you need to keep track of which pages you've sent. You need to keep track of which ones need to be refreshed and when they need to be refreshed. And this is really hard to get correct. So lastly, well, not quite lastly, onboarding, it's a real problem. And the reason I say this is because the dream is that the web devs will come in and they're going to write React Native because they know this better than I do. I am not a JavaScript developer. I will tell you that outright. Kotlin is my language. And so when I work in JavaScript, I am a beginner starting from scratch trying to get up to speed. And when we want web devs to come in, What we're ignoring is that this change almost always happens from the native side because we understand the problems of native and we're the most motivated to fix it. So if you look at any company doing this at scale, it's always started from their native team adapting web technologies and not vice versa. And what that means is that we as native developers often don't work in reactive paradigms. I was lucky that we had re-implemented Cycle.js natively, but most people don't do that. And this is a huge paradigm shift, not just with the reactive programming, but also with Flexbox. It was a huge pain point when I made my switch. And on that note, anybody who's been in this room has probably been thinking to themselves, JavaScript, JavaScript, JavaScript. And that's because on native, we have the benefit of really amazing languages. Objective-C has quickly given way to Swift, and Java is soon giving way to Kotlin. It is my hope. And what that means is that we have strongly typed languages, and the compilers will do half of the work for us. They will tell us when we've done something stupid, and they'll suggest how we fix it. And that is amazing. And when we use JavaScript, we give a lot of that up, and there are tools that we can use to give up a little less of that. We can, put TypeScript in there, but it's not the same. And this is a trade-off that we have to be aware of because where we gain stuff for other features like quick development time, we're losing it here in some regards. So now that I've gone through pros and cons, I want to talk about some things that don't fit into either of that. These are our discussion points where if you're going to sit down and say, wow, we can really speed up our development with React Native, let's adopt it, people are going to push back. So to start, native is always going to be faster. It doesn't have to pass things around. It doesn't have to do all this thread switching, or not nearly as much as React Native. And so if you do native right, it is always going to be faster. And what that means is that at the end of the day, when you're talking to your manager, you have to make a case that React Native is going to make you so much better as a developer in terms of feature velocity that it is worth this small performance hit. Additionally, what you're doing is you are placing yourself on a continuum of device power and iteration speed. So obviously, if you are fully native, you are at the maximum device power. You have access to everything that phone has to offer. If you are fully React Native, you are all the way at the other end over there on iteration speed. You are going to be able to move as fast as it is possible to move on native. If you have a hybrid app, you're somewhere in the middle. And the answer of where you want to lie on that continuum is going to dictate how much React Native you want in your app. If you want a little bit of iteration speed, like slightly hybrid app. You might do one screen, one feature. If you need iteration speed above all else and you don't care about performance or not nearly as much as the iteration speed, like maybe you're at a startup who needs to push apps or die, well, you're going to go a lot more React Native. So also, this is always something of note for anybody who's using Android. It ships. It'll make your app bigger. You are going to need to worry about DEX limits. This is just a fact of nature. It ships with 2 JOS core supports, x86, and for ARM. You might decide you only need one. It ships with Fresco. You might decide you don't need that. You have your own image processing library. This is something to talk about with your platform team because they're really going to care. Also, still not at 1.0. We know this, and what does that mean for you? It means that we don't have the guarantee of stability. We don't have the guarantee that this won't break. We don't have any of the guarantees until it reaches 1.0, which means that we might have to repeat work. And that's something that your manager's really going to have to be okay with. You're going to have to buy into the fact that this is experimental and it's only been out for a year. Additionally, there are user data and autonomy concerns, which is that we are taking the choice of update from the user. So before the user, if they wanted to stay on your app, they could. No longer, though. Now we're saying, hey, we want you to update. We're going to do that. And that's something to consider because it's going to piss off a lot of people, I know from app reviews. Also, that line with Apple is fuzzy. I cannot reiterate it enough. You're going to have to walk that line, and you're putting yourself at some sort of risk of crossing it. Additionally, new deployment processes. We've talked about this before. You already have deployment for Android and iOS. You're going to have to create an entirely new system if you're going to do code push. And you're probably not going to be able to get rid of your specialists. This is a huge selling point, but it's not the reality yet. So if you're going to talk to your manager, they might say, so we're just going to be able to write it once. You're going to have an honest and frank discussion about the fact that this is not quite yet where React Native is, although it might be where the future of React Native is. And lastly, you're trading a faster development loop for more complex architecture in your app. So your developers are going to be able to move faster, but they're going to have to maintain more code. We have a more complicated process. Code is coming from 2 places now. So just to conclude, I want to say that we would do this again in a heartbeat. And why is that? Because we had amazing triumphs bringing React Native into our app as a startup. We were able to move faster than anything I've ever seen. We hotfixed tremendously impactful bugs on the fly on days when people were writing about us in the press, which we could have never gotten through the App Store. And our design and development of features really, really made us give users a better experience because we weren't locked into such a time frame. We could change things and iterate and give them the best user experience in the shortest amount of time. Now, we did stumble. They didn't have 3D touch when we wanted it. We had to write that ourselves. We had to assign 2 people just to the database communication as opposed to just me handling everything else, which should tell you how complicated it is. And of course, we fought UI dropped frames, just like everybody else. So the last thing I'm going to leave you with today is that if you take one thing away from this, I hope it's this. If you have a part of your app that will benefit from experimentation, from hot-pushed bug fixes, from the ability to move fast and develop quickly, React Native is an amazing tool for that. But it doesn't need to be your whole life or your whole app. If the rest of your app is working, if it's stable, if it is doing heavy processing and it's likely to stumble in React Native, you don't need to make this switch wholesale. This is a targeted tool that can be used to great effect in small quantities, and it doesn't need to be all or nothing. So with that, that's all I have for you today. Thank you for being here, and if you have questions, I'll take them later in the lobby. Thanks.